Hello students, my name is Dr. Gajendra Purohit. I upload videos for engineering, mathematics and B.Sc on our YouTube channel. My channel can be very helpful if you are preparing for any competitive exam where higher mathematics is asked. Recently, I have uploaded Laplace Transform 2.0. Before that, I uploaded topics like Laplace Fourier and Z around 4 years ago. I have uploaded all these mentioned topics on the channel where I have explained them in a proper manner. In this 2.0 course, we will include some more things here, and we hope that this series is definitely going to be helpful for you in understanding concepts better. So today I am going to start the Fourier transform, in which the inverse Fourier transform, and then Fourier sine, Fourier cosine and the discrete Fourier transform. I will be going to cover all of these topics here. Now let's get started. So the application of Fourier transform mostly lies in engineering. However, here we will learn how to solve mathematical problems using this. Now let's say we are given a function af x and we need to find its Fourier transform. So how do we find it? Moreover, you should also know how to find the inverse Fourier transform, because whenever we study transformations, the inverse is very necessary. Before this, when I taught Laplace, I also told you that if you are taking the Laplace transform, you should also know the inverse Laplace. Normally, this has large number of applications in engineering. Whenever we are given a time domain function, how do we convert into frequency domain? So it is used in this case. Anyway, let's get back to the question. If we are given a function fx, and if we talk about its Fourier transform. So, what will be the Fourier transform here? We will get fs is equal to 1 upon root 2 pi minus infinity to infinity and e raised to the power of iota sx fx dx. If we talk about the inverse Fourier transform, it is also called the complex Fourier transform. So here it is e raised to the power of iota sx, and the real parts and the imaginary parts are included. So this is why we call it the complex Fourier transform. And if we take fx to the other side, so this fs will go to the other side and it will become 1 upon root 2 pi. And it becomes minus infinity to infinity of e raised to the power minus iota sx fs ds, right? So the fs will go to the other side, becoming ds. Iota sx will become minus iota sx. Sometimes the formula in some books is slightly different. So students say that the formula for the Fourier transform is given different in our books. So students, it is given minus infinity to infinity of e raised to the power iota sx, and fx dx is given. And if we talk about the inverse Fourier transform here, in this case, the formula is 1 upon 2 pi minus infinity to infinity of e to the power minus iota sx fs ds. So, you will find this formula is given in some books and another formula in some books. But when we solve the question, it won't make any difference. Because when we take the inverse of 1 upon root 2 pi, when we will substitute this fs value here, root 2 pi will become 1 upon root 2 pi. So, it won't make any difference, it will be the same. So, what I have explained to you was that the function fx should be defined from minus infinity to infinity. This should be uniformly continuous in the finite interval plus minus infinity to infinity, and mod fx dx should converge here. If this happens, then its Fourier transform is calculated like this, and its inverse Fourier transform is calculated in this way. Clear? This is how we solve it. Now I'll try to explain how the question is asked in the exam. Generally, it is asked in two ways. Find the Fourier transform, or sometimes you will be asked to find it and prove it. If we are only asked for the Fourier transform, then we will apply it. But when we are asked to prove the Fourier transform, then we will have to use the inverse Fourier transform as well. And I will try to explain you how shall we do it. The question is fx is equal to 1 for mod x less than or equal to a and 0, where mod x is greater than a. Whenever we are given this, it means that the value of x is between minus a and a. And what is the value of the function? The value of the function is 1. Whenever it is given other than this, then what is the value of function? The value of function will be 0. So we know that whenever we take the Fourier transform of any function, so we are aware that the value we will get is fs 1 upon root 2 pi minus infinity to infinity. It is e raised to the power of iota sx fx dx, right? The function fx has a value of 1 when x is between minus a, and on all other values it is 0. This will be 1 upon root 2 pi and it will be integrated from minus a to a. Now, we will put fx equals to 1. So, it will be e raised to the power iota sx dx. Now, when we solve this, so what can we do here? We can expand this. So, we will write minus a to a and we will get cosine sx. We will write plus iota sine sx. We will get this multiplied by dx. Now let's separate these. So 1 upon root 2 pi integrated from minus a to a, it will be cos sx dx plus iota upon root 2 pi, limit from minus a to a, and then sin sx dx. Is it clear? If you have watched my previous Fourier series video, there I had explained the concept of even and odd. Since cos is an even function, right? So its value from minus a to a will be twice, okay? Therefore, the cos value will be twice here upon under root 2 pi and limit 0 to a, and here it will become cos sx dx. When we discuss sine function, it's an odd function, and whenever there is an opposite limit in odd function. So students, in that case, what will be integration of this function here? It will be 0. Now, we will do its integration. When we will integrate it, it will be 2 upon under root 2 pi, and the integration of cosine will be sine. So, it will be as x upon s and limit 0 to a. Thus, wherever it is x, we will put a in place of x there. We will get the value as 2 upon under root 2 pi, and we will get this as sine s a upon s, and when we will put 0, the sign of 0 will be 0. So, this is what we got as its Fourier transform. If you are asked what is the Fourier transform of this example here, then this value will be its Fourier transform. We will get its answer. But whenever we talk about proof, what will we do in that case? So, we will take the inverse Fourier transform for the proof. I will substitute this value of fx here and erase this. And the value of fs that we get from the Fourier transform, I will put it here so that we don't have any problem. So now, the value of fs, 2 upon the square root of 2 pi, and the sine in bracket sa upon s. So we will get this as the value of fs. Now we need to prove it. So we will take inverse. I will explain you how to take the inverse. So whenever we have to prove it, we will use the inverse Fourier transform formula. This is the formula for Fourier transform. And if we talk about its inverse, then this fx will come here. And this will be 1 upon the square root of 2 pi integrated from minus infinity to infinity. So students, it will be e to the power of minus iota sx fs ds. We have this value of fs here which we derived from the Fourier transform. So we will put this here and the fx will be put here. Therefore, what I will do, I will put this value. Therefore, we will get the value as 1 upon root 2 pi. From minus infinity to infinity, this will be 2 sine sa upon s. And as you know students, we already had this root 2 pi, right? Multiplied with e to the power iota sx, and I will put the value of fs as ds is equal to fx. So what will we get here? The value of fx will be 1. Mod x is less than or equal to a and 0, where mod x is greater than a. We have to prove sine s upon s. Now what will we do students? We don't need this term e to the power iota sx in this proof. So here we will put 0 in place of x. Since we are getting value of x between minus a to a. So note that I can take the value of x as 0 here. As you take the value of x as 0, this 2 root 2 pi will become 2 pi, so this will come out. What will we do here? Limit minus infinity to infinity. And this value of x is 0, so this will also be 0. If we remove this out, then it will become sine sa upon s ds. Because we took the value of x as 0, the value of the function at 0 is 1. Now what we will do? Minus infinity to infinity. This 2 is cancelled out, 1 upon pi is left. We will cross multiply with pi. So here it will become sine sa upon s ds is equal to pi. One thing you need to keep in mind here is that this function is in s, and since it will be an even function. Why it will be even? Because this is also odd and it is also odd in the denominator. So odd upon odd here will be an even function. We can write this as twice of, and it will be limit 0 to infinity. And we will get sine sa upon s ds, and we will get the value equals to pi. Now what we will do here? It is asked sine s upon s. So what we will put in place of a? We will put 1, and it is your choice. That you can put any value here. So what we will do? We will put 1 in place of a. When we place the value of a as 1, then it will be limit 0 to infinity. And we will get value of sine s upon s ds. This 2 will go here in the denominator. So what will be the answer? Pi upon 2. What will be the value of second part? Limit minus infinity to infinity sine as cos sx upon s ds. I'll explain by proving in the second part. When proving the second part, you need to do the same till here. So here you have to prove that we are getting limit minus infinity to infinity sine as cos s x upon s ds. What we will do here? We will keep this as it is, and we will take this term out, so it will be 2 upon 2 pi. And this will be minus infinity to infinity. It will be sine sa upon s. And if I solve this, so we will get the value as cos sx minus iota sine sx. This will be multiplied by ds. And we will get its value as 1 here, where mod x is less than or equal to a, and 0. Where mod x is greater than a, what will be its value? We will separate real and imaginary parts. 2 is cancelled out. So it will be 1 upon pi. Limit minus infinity to infinity, this will be sine sa. And here we will get cos s x upon s ds, right? And here we will write minus iota upon pi, and this will be limit minus infinity to infinity. This will be sine SA and then sign Sx upon, what are we getting here? We have S multiplied by ds, right? And its value is given as 1, where mod x is less than equals to a and where mod x is greater than a. Because we know whenever we discuss this mathematically, the real part is always equal to the real part and the imaginary part is always equal to the imaginary part. So we can do here iota multiplied by 0. Then what will be the value here? It will be 0. This was one way. The second way is if we look here, this function is odd. And what will be its integration value from minus infinity to infinity? It will be 0. Thus, the only value that will remain here is this one. So, students, we will get this as 1 over pi and minus infinity to infinity. Sine SA cos Sx upon S ds, and this value will become 0. So, we will get limit 0 to 1. Here we will get mod x is less than a and 0 mod x is greater than a. Okay, so multiply this pi over here. Now from this we will get minus infinity to infinity. Sine SA cos Sx upon S ds. So if pi will be multiplied here, where mod x is less than or equal to a and 0, mod x is greater than a. So students, what will we get here? We will get its value, and that is how we can prove it. I have tried to explain here what is the method to prove. If you will look here, you will notice we can easily prove it this way, right? Here you can see we will put the value of x as 0, which I told you earlier. Then after that, we will put the value of a, which is 1. So we will get the answer. So I explained how we will solve it. If you are preparing for exams like CSIR NET, IIT-JAM or GATE, then our books are available on Amazon. The link will be in the description to purchase them. The books are also available on Flipkart. The next question asks you to find the Fourier transform of this. And you need to find its value. Whenever this type of question is asked, so we take the Fourier transform. Next, we will find its inverse Fourier transform. So we will find the value. You are told here that mod x is less than or equal to 1. This means value of x is between minus 1 to 1, and in that case its value is 1 minus x square. And what is given in the remaining cases? We have 0 here. We know that the formula we have for this Fourier transform is fs is equals to 1 upon square root of 2 pi minus infinity to infinity. We will get the value as e raised to the power of iota sx fx dx. Since the value of fx is given between minus 1 and 1, so we will put this. So here we will get fs is equal to 1 upon root 2 pi. This will be from minus 1 to 1, the value of fx. We will put this, but as we remove d. So first I will expand this cos sx plus iota sin sx and value of fx that we are getting from here is 1 minus x square dx. So we will separate this. So we will get fs is equal to 1 upon root 2 pi. Limit minus 1 to 1, and it will be 1 minus x square cos s x dx, and write plus iota here. So here we will write iota upon root 2 pi. I have separated this, and here it will be limit minus 1 to 1, 1 minus x square sin s x dx. Now we know that whenever we have opposite limits and it is an even function. I had also explained this concept of even and odd in the Fourier series video in a detailed manner. I will again explain to you that if we have any function of this kind, an odd function, it means that if you replace x with minus x, the minus will be taken out. So whenever we have opposite limits, then the value of integration is 0. And if we have an even function, it means that if you replace x with minus x, there is no difference. For example, in this even function, it doesn't make any difference if we keep it equal to this. So this will be 0 to a, twice of x square dx. Is that correct? You need to understand this. When we have a function that is either odd or even, then this concept is applied. We will also apply it here. So this is an even function and this is also even. So even is multiplied by even. We have even term here, but this is odd term. So odd multiplied by even will be odd, and its integration will be 0. Only this will be left here. What will be the value from here? It will be twice of, right? And under root 2 pi, this will be limit 0 to 1. 1 minus x square. And it will be cos s x dx. Now what we will do? We will find its integration by isolate. So we will get its value from fs is equals to 2 upon root 2 pi. What will be its integration? First of all, what did we do? We left 1 minus x square. And if we find for cos, then this will be sin s x upon s. What we will do now is take the derivative of this. So write minus. I would like to briefly explain here about integration. If you have to do integration of cos s x here, right? Okay, this is given. So what will we do? Whatever limit is given, like 0 to 1. So 1 minus x square will be left. And it will be cos s x dx minus the integration of the term which is left will come here. Do you remember? Then we do the integration of cos sx and then the integration of the whole thing. So we get dx. Then what we will do here? We will find its value and we calculate the value like I have told you. And as you know, this concept is about the islet, which is the concept of bipart integration, which we learned in 12th grade. In the same way, we will solve this here. So when we differentiate 1 minus square here, so this will be minus 2x and we will again integrate cos. This will be sin s x upon s and here it will be dx. I will apply the limit from 0 to 1 here. And I'm also putting the limit 0 to 1 on this. Limit on integration will be distributed. Wherever it is x, we will put it 1. And if we put 0, then value of sin 0 will also be 0. So when you apply this limit here, the value of its integration will be 0. Now pay attention what we will do. The value we will get here. We will write it. This minus and minus becomes plus. So now let me write this here. It will be fs. This minus and minus become plus. And on taking the 2 common, it will be 4. And in the denominator, we will get under root 2 pi. See, this 1 upon s is also common here. So it will be 0 to 1. And here it will come x sin s x dx, right? Thus we will find the integration of x sin s x. Rest will come outside. So here I will explain you the integration of this term. Now we will get the value here as fs is equal to. What will be its value? It will be 4 upon root 2 pi 1 upon s, and we will do its integration here. So pay attention what we will do. We will leave x and integrate sine. So integration of sine will be minus cos x upon s minus. The derivative of x is 1 and derivative of sine will be done twice. First it will be cos and then it will be sine. Minus will become plus sin sx and it will be done twice, so s square. The limit will come 0 to 1 here. Now when we will put its limit. So it will be 4 upon. We will take this value root 2 pi 1 upon s. Wherever there is x, we will put 1, right? This will become minus cos s upon s here. It will be sin s upon s square. At 0, this value will become 0 and this as well. Now what we will do? We will take the LCM of s square and simplify it a bit. 4 upon root 2 pi, we will take the LCM of s square. So this s will become s cube. And this will be sin s minus s cos s. So students, this is what we will get as its value here. Now what do we do? So here we take its inverse because we have to prove this. Whenever we talk about proving something or finding a value, in that case, we use the inverse Fourier transform, right? So what is the formula for the inverse Fourier transform? It is f x equals to, we get this as 1 upon root 2 pi, minus infinity to infinity of e to the power minus iota s x, and here we will get this as fs ds, right students? Now what we will do? We will put this value of fs here. So on solving, we should get this fx again. If we take the Fourier transform of this and obtain this value, then taking its inverse should result in this. Is that clear? So we will use this. Pay attention, I am writing this here. If I write its value on this side, then it will be 1 upon root 2 pi and we will get minus infinity to infinity. We will take this value. It will be cos s x minus iota sin s x. So we expanded this. And this is the value of fs, right? So it will be 4 upon the square root of 2 pi. And then here it will be sine s minus s cos s upon s cube, right? And keep this in mind, this is cos s into ds is equal to, here its value will be 1 minus x square, where mod x is less than equal to 1, and for 0, where mod x is greater than 1. So what we did with the value of fs? We placed it here and the value of fx here. Now what do we do in such questions? As I mentioned earlier, imaginary part is equal to the imaginary part. And value of its imaginary part will be equal to 0, so the iota sx term will be eliminated. This term will be left, so I'll take it out. This root 2 pi into root 2 pi will become 2 pi minus infinity to infinity. Cos sx and it will be multiplied with this term because this term will become 0, right? Then we will get the value as sin s minus s. Cos s divided by s cube into ds equals to 1 minus x square, where mod x is less than or equal to 1. And 0 mod x is greater than 1. When you have to prove, so here in the cos term, we need x by 2. What do we need here? We need x by 2, which means 1 by 2, right? So what are we going to do? Look, x should be in place of s. So we will put x in place of s later on. First, we will do 1 upon 2 here. Basically, we will put this value. Pay attention to this concept. It is important. We will put x is equal to 1 by 2. So we will replace x with 1 by 2. So when we will put 1 by 2 in place of x, we will cancel this. And then we will get 2 by pi here. Limit minus infinity to infinity. This will be cos s by 2. And then here this term will be sin s minus s cos s divided by s cube multiplied by ds. So students, we know that mod x is less than 1 means that the value of x is between minus 1 and 1. Since we put x 1 by 2 here, so it will be within these limits. and the value of this will be equal to this, which means it will be 1 minus 1 by 2 whole square. We will simplify this. Now pay attention to what is given in this proof. What is the difference here? Here instead of s we have x, so don't worry. Now what we will do? Substitute. S is equal to x, clear? And if we take this 2 by pi to the other side, but I will need to clean the screen a bit. So I'll explain you on this side. Now students, as soon as we replace s with x, this ds will become dx. Okay. So we will put this value here. Then we take 2 by pi to the other side. Now pay attention, I'll do the remaining calculation here. What we will get here? This 2 by pi will be multiplied. On the other side, we will get minus infinity to infinity. It will become cos x by 2. And then here we will get sin x minus x cos x divided by x cube. And here it will be multiplied with dx. So this 2 by pi will go to the other side and become pi by 2, and we will get pi by 2. Now if we calculate this value, it will be 1 minus 1 by 4. Thus we will get 3 by 4. We are asked for 0 to infinity. So this is minus infinity to infinity. Therefore we will make it twice of from 0 to infinity, as this function is becoming even. So this is even. And here the numerator is odd and the denominator is also odd. So odd multiplied by odd gives us an even function. Clear? Since this entire function is even, we will make it twice. It will be twice of from 0 to infinity. Since x cos x is in the outside, I'll take the minus sign common. So students, this will be cos x by 2 and this will be x. Cos x minus sin x upon x cube dx is equal to, it will be 3 pi by 8, right? Now divide this by minus 2 as well. So if we divide it, it will be 0 to infinity. Cos of x divided by 2, and here it will be x cos x minus sin x divided by x cube multiplied by the dx. And when this will be divided by minus 2, so its value will be 3 pi by 16. Then we will get minus 3 pi by 16. Thus we can very easily prove it in this way. This is an important question and it is also asked in the exam. Look here, it is a very good question. You are being asked again to find the Fourier transform of fx. It is given where 1 minus mod x upon a, where mod x is less than a, and 0 where mod x is greater than a. Is it clear? So whenever we have a question like this, the first thing we will do is we will redefine this function, right? So students, we know what is the value of fx here. The value of fx will be between minus a and a, right? The value of fx is between minus a and a. But we know what is the definition of mod x given here. And if we talk about mod x, so we know that when x is less than 0, we have minus x. And when x is greater than 0, we have x. So if we will redefine this function here, it will be equal to 1. And when we talk about value of x from minus a to 0, right? Are you getting my point? I mean, if we talk about value of x between 0 and minus a, in that case, this mod x will become minus x. So its value will become 1 plus x by a. Is it clear till here? If we have value of x which is greater than 0 and less than a, then keep this in mind that in that case, the value of x in mod x remains positive only. This means x is greater than 0, so it will remain as plus x. So this minus sign will remain as it is here. And when value of mod x is greater than a, we will get 0. So you need to understand this. You can easily solve the rest of this question now. We just need to apply the formula for Fourier transform. You can solve by applying the formula. The formula for the Fourier transform here is fs is equal to 1 upon root 2 pi, here limit minus infinity to infinity. This is e to the power of iota sx, and here fx dx. Now what we will get here? Pay attention when we will discuss about fs. So fs will be equal to 1 upon root 2 pi. Here we will get its value between minus a to 0. Then value of fx will be 1 plus x by a. And this will be e raised to the power of iota sx, and it will be dx. When we get its value as 1 divided by the square root of 2 pi, then we will get from 0 to a, right? And in that case, we will get 1 minus x by a. And this will be e to the power of iota sx dx. If you want, you can expand this e to the power iota sx. Then I will write this as 1 divided by the square root of 2 pi here. Or it's better to do it through simple integration. We can expand this and integrate it. So if we apply I late here, what will we get? 1 plus x by a is left, and here it will be e to the power iota sx. It will be 1 upon iota s below, minus do derivative of this term. So it will be 1 upon a, and we will do it twice. In this e to the power iota sx, we will get iota s and again iota s. So this will be e to the power of iota sx upon iota square and s square. Students, this will be iota square s square, and the limit will be from minus a to 0 now. Now if we talk about this, we will get it in the same way, 1 upon root 2 pi. So when we integrate this, the integral will be 1 minus x by a is left. Here we will get e raised to the power of iota x divided by iota s. When we take its derivative, it will be minus 1 upon a since it comes in. I let these two minus sign will become a plus. And this will be e to the power of iota sx upon iota square. And here s square and here it will be limit 0 to a. You just need to understand this. So when we will apply the limit here, what will we get? First of all, we will substitute f s equals to. We will get 1 upon the square root of 2 pi here. So we will replace x with 0 here. Thus x will become 0 and e to the power 0 is 1. So we will get 1 upon iota s. This will be its value. Now we will put 0 wherever there is x, as e to the power 0 is 1 and iota square is minus 1. So this will be plus 1 upon a s square. So you should pay attention to this. Now if we will put x as minus a, so minus a upon a becomes minus 1. Therefore, this whole term will become 0. Students, if we put minus a over here, then minus minus will become plus because it is the second limit. So here we will get 1 upon a and e raised to the power of minus iota sa, and the value of iota square is minus 1, right? So we need to put this minus sign back. Now from here what will we get? As its value here, it will become minus 1, right? So students, you can see this will become minus 1, and now as you know, the value of iota square is minus 1 and when second is minus. Meaning if we apply second limit after taking the first limit as negative, then it will become negative. Now let's discuss this. So this will be 1 upon the square root of 2 pi, and now we will put it a, then it will become 0, right? This a upon a is 1, so 1 minus 1 is 0, right? And we will put a here. The value of iota square is minus 1. So this will give us the value minus 1 upon a here. This will be e to the power iota s a divided by s square and minus the second limit. When we will subtract the second limit, so 0 will be in place of x. We know e to the power 0 is 1, therefore the value will be 1 upon iota s. And here also we will put 0 in place of x. So iota square is minus 1. And this will be negative, so negative negative becomes positive. And from here we will get its value as 1 upon a s square. So we will get this as its value. If you will look at it carefully, some of the terms are getting cancelled. If you look, one term is clearly getting cancelled. We have all these here. So this term here, it will cancel out and what others will be left. So if you discuss this, then finally what will we have? Pay attention here. Thus students, here we will get fs is equals to 1 upon root 2 pi. And this will be 1 upon a s square and 1 upon a s square. So the answer will be 2 upon a s square. And you can also notice some things are common. So this minus and this minus sign is common here. Therefore, we are getting minus 1 upon a s square common. This will be e to the power iota sa minus, sorry, it will be plus e to the power minus iota sa. This is what we will get as its value here. Now if we will solve this again, so here we will get f s is equals to 1 upon, in denominator this will be root 2 pi. And 2 upon a s square, now what we will do here? We will multiply and divide by 2, so we will get e to the power of iota sa. And it will be plus e to the power of minus iota sa upon 2, right? So it is different from here. And we have the value of this term as cos s a here. So what we will do here? We have 2 in common from above. We will get the value 2 upon root 2 pi. And here this will be 1 upon a s square minus 1 upon a s square. And here it will be 2 cos sa. Now let's simplify it. This is getting cancelled. So here we will get the square root of 2 divided by pi. And this will be 1 minus cos sa divided by a s square. And now it is done. So this is what we have as its Fourier transform. In this way, we can easily find its value. And here this question is for the comment box. How much time did you take to solve it? Please comment and let me know. If you want to see my previous videos about the Fourier transform series that I uploaded earlier, you can watch them from here. If you want Laplace transform videos, then you can check it out on this link and subscribe to the channel. Thank you very much to all of you. Thank you. Bye.